We're going to be looking at class inheritance in this lesson. So let me create a new file. Okay, so let's look at what inheritance is. It says here that supports the concept of inheritance, which is the ability of a program to create new classes from an existing class. The class that is extended to create newer classes is called the parent class or superclass. The newly created classes are called the child or subclasses. A class inherits from another class using the extends keyword. Child classes inherit all properties and methods except constructors from the parent class. This is just a simple demonstration of what the syntax looks like. Right? So we are going to see that, but let's proceed. Class inheritance. In the following example, we are declaring a class shape. The class is extended by the circle class. Since there is an inheritance relationship between the classes, the child class, that is the class K, gets an implicit access to its parent's class data member. Let's see what this means. I believe they meant circle here. Right, I believe they meant circle here, not car. So, they gave us an example of shape. Alright, so let's copy this class and paste here. Alright, so shape is a class, and shapes have different characteristics, like I don't know, area. Okay, area is supposed to be a double, double surface area. Okay, let me make it nullable. Alright, and then what else? Okay, let's just, I don't know, define color. String color is black. Alright, so now we have this class. Alright, shape, and we have another class, circle. Now we know that circle is a shape. Alright, and because we know that circle is a shape, we can do this extends shape. Alright, so this right here is inheritance. Okay, circle is inheriting from shape, so that is actually what this extends is doing. Alright, it is this circle inheriting all the properties and methods of shape, so that when we when we create an object or instantiate circle, okay, we will be able to have access to all the properties and methods of shape, like surface area, like color, like calculated area. Now do not name your variables like this. Okay, this convention is for naming files. That's where you have underscore, unless you're creating a private variable, then you can have or a private function or a private class, right? Any of your values, any of your data types can be or even variables can be private or functions, right? So unless you're creating a private variable or function or class, do not use underscore to name them. All right, you only use underscore when you want to create a class name, just like I did here. All right, so this is wrong. Instead, you name it like this. All right, calculated area. Yeah, that is actually much better. All right, so this is it. Okay, I've been able to access. Now you can see that Circle doesn't even have anything inside. It doesn't have, apart from its constructor, it doesn't have anything inside, right? No properties, no method, no nothing, right? But because it is inheriting from shape, okay, because it's inheriting from shape, it actually inherits all the properties and methods of shape. Okay, same thing as triangle. If I say class triangle extends shape, the same thing happens. Okay, so triangle inherits everything from shape. Exactly. So that's that. Alright, so we have types of inheritance. Single inheritance, where every class can at most extend from one parent class. Multiple inheritance, a class can inherit from multiple classes. That doesn't support multiple inheritance. So this multiple inheritance is not our business, since that doesn't even support it. Alright, and then we have multi-level inheritance. A class can inherit from another child class. For example, if I have class, let me call this small circle. All right, small circle. It can inherit from circle as well, even though circle is a child class already. It is inheriting from shape. All right, another class can still come and inherit from circle. All right, so that is the and that is what is being talked about here. Okay, that is multi-level inheritance, and they gave examples here. So next we have that class inheritance and method overriding. So method overriding is defined as a mechanism by which the child class redefines a method in its parent class. Okay, method overriding, a mechanism by which the child class redefines a method in its parent class. The following example illustrates the same. Okay, so let's see what is here. We have a parent class with a method m1, okay, and then a child class which is extending from parents, inheriting from parents, and then overriding m1. So this is one of the things we have in inheritance. All right, the ability to override methods, just like here now. I can decide to override this calculated area. All right, calculated area in this. Let me do it in small circle. I can also do it in circle, right? But I chose to do it in small circle. So I'll select this one, override calculated area. All right, and this super dots cal area is actually calling the calculated area of the superclass. All right, the calculated area of the superclass. Remember, this is the superclass. sorry, this is the superclass. The circle in this case is the superclass. All right, because inside this particular class, I am inheriting from a superclass, even though this superclass is actually a child class of another superclass. All right, but I am inheriting directly from circle. So even though I am overriding, I am still calling this. All right, that is why this will be printed. All right, this will still be printed because I am calling super. Okay, I can for instance, I can print here. I can print super dots and color. Okay, super dots color, and I'll get black. All right, so black is being printed. Why is it being printed 2 times? Okay, because of this. Wait. Okay, yeah, this. All right, so I'll just remove this. No, because of this. Okay, so I'll still have black printed. All right, because it's the super class. But if I remove the super, I'll still have black printed though. Right, unless I define color here again, string color, and set it to maybe something else like white. All right, then I'll have white printed. Okay, but if I decide to say super dot color, all right, this super simply refers to what is in the super class, and that is black. All right, so I hope method overriding makes sense now. All right, this is method overriding. That is simply what it is. Okay, so we have actually looked at all this. I have explained static keyword and super keyword. Okay, so I think that's it for all right. I think that's it for inheritance. Okay, we are done with inheritance. So let's see what is here in object. All right, let me just go through this. Okay, so now I know you have been hearing about object-oriented programming. All right, so this is actually a short explanation. It's not a complete explanation. All right, I'm still going to dive deep into. In fact, we are already discussing object-oriented programming. All right, but we are still going to bring it all together later in this course. So it says here, object-oriented programming defines an object as an entity that has a defined boundary. All right, you know what an object is? Like when we created objects of classes, all right, this is an object. This T is an object of a class, all right. So, and that is object-oriented. Okay, it is oriented around the concept of object. Okay, so it says OOP, object-oriented programming, defines an object as an entity that has a defined boundary. An object has the following: state. State describes the object. All right, the fields of a class represent the object's state. Okay, the field of a class represent the object's state. So it says the fields of these classes. The fields, these are the fields, represent the object state. Behavior describes what a class can do. Okay, this is actually talking about the methods of the class. All right. Identity, a unique value that distinguishes an object from a set or of similar other objects. Okay, two or more objects can share the state and behavior, but not the identity. So every object is unique. Okay, every object is unique. That is simply what it says. The period operator is used in conjunction with the object to access a class data members, a class data members. All right. So um, these dots right here, okay, and then these dots right here, and these dots right here are known as the period operators. All right. So it is used in conjunction with the objects to access a class data members. All right. And then they gave us examples here. And then we have this operator called the cascade operator. All right. So let's see. It says the above example invokes the methods in the class. However, every time a function is called, a reference to the object is required. The cascade operator can be used as a shorthand in cases where there is a sequence of invocations. Okay, so the cascade operator can be used to issue a sequence of calls via an object. So the above examples can be rewritten in the following manner. Okay, all right. So this cascade operator, right, which is made up of two dots, can actually be used to invoke a sequence of calls, right, via an object. I'm going to show you a very simple example. Okay, how many methods do I have in this class? How many methods? I have two methods. Okay, so I'm going to let me just attach a print statement here. Print nice. No. 9 years. All right. So I have an object already. Do I? No, I do not. Okay. Let me just create. Or should I do it here? Let me do it here. So I want to create an object. All right. Okay. Now you know that normally we can do this. We can call my car dot disp, all right, which is the first method. All right, is normal, and we can also call my car dot car age. All right, so we can call these methods separately, but we can actually also call them at once. All right, we can actually also call them at once using the cascade operator, these two dots. All right, so my car cascade, disp cascade, carriage. Okay, so this is what the cascade operator is for. You can call two methods on one object. Okay, you can actually also do the same thing in, let's say, if you have a string name equal to that programming. Okay, I can actually also say name cascade contains contains a, you know what this will give, right? Yeah, it's going to give true. because that programming contains a. It contains a here and here. So another method, the code units at index 3. Okay, so you can actually also do this. Okay, instead of calling them one by one on name. Right, so that is what the cascade operator does. I'm not printing, so nothing is being printed from this. All right, so that's that. Okay, not quite what we expected. Alright, anyway, maybe I will look into this again, but I just need that to explain this operator. Okay, so you already know about the toString method. Alright, no need explaining, I believe. So let's end this class and continue in the next lesson. Thank you.